Hello everyone and fellow Redstoners, welcome back to another video, and in this video we're gonna see about data aggregation and its role in blockchain oracles. Let's get into the video. The first thing we would be seeing is that the role of data aggregation. Data aggregation improves the quality of the oracle data and helps oracles meet the requirements in many ways. Aggregating data from different sources increases the value correctness because even if some small subset of sources eventually corrupts, it should not corrupt the aggregated value. So the aggregated value usually represents a more fair or more correct value, and additionally aggregation improves data availability because even if some sources stop working, the Oracle service will still be able to function properly. The main product market fit for oracles today is the provision of pricing data, which is very useful for creating synthetic and derivative assets, insurance, lending, and many other protocols. That's why guys, this video is mainly focused on the methods of aggregating price values. Now let's see the key aspects of data aggregation. And the quality of data delivered by an Oracle service depends on two main criteria guys. The first one would be data availability and the second one would be data correctness. Let's see the first one. Data availability. This means the Oracle data should be always available for end user or smart contracts and should be updated with the promised frequency. The second thing would be data correctness, and it may be defined in different ways and usually depends on the type of the data. For example, correctness of objective data like results of given football match can be easily verified, but with less objective data like ETH token price denominated in USD, it can be way more difficult to define correctness. Now let's see the first model here, which is average price value, and the first aggregation algorithm that comes to our mind is calculating the mean value. Despite of it looking simple, it has significant disadvantages because it is not resistant to manipulation by even a small subset of corrupted sources. Let's say you want to get the ETH USD value from 5 different exchanges, where 4 of them claim that the current price is around $2,000, but one of them insists that it's only $1. Then the average value is $1,600, which is too deviated and cannot be considered correct. That's why usually mean value calculation as well as other aggregation methods are combined with an interquartile range filter, which helps to filter out outliers and market manipulations. So next thing we would be seeing is median price value. So there's another approach which uses a median value calculation, and it's way better than the average value and definitely more resistant to manipulations by corrupted sources. But even this method cannot be considered a perfect way to calculate price value. Now let's take the same ETH USD value from one large crypto exchange, let's say 100 million daily trading volume on ETH USD market, and 4 small ones, around 10k daily trading volume on ETH USD market. And the large exchange provides value $2,000, but all the small ones with less than $1,900. Then the aggregated median value here will be less than $1,900, but as you can guess, it's not close enough to the real market value. Now let's see the next method, and one of the best aggregation method is the volume weighted average price calculation. This is a trade based price determination that takes into account the different volumes of trades in different sources. The more trading volume a source has, the bigger the weight of its price value. Sometimes VWAP is also combined with the interquartile range filter to filter out outliers. See VWAP-IR. It is possible to calculate the liquidity weighted average price LWAP aggregated from multiple decentralized exchanges, which has similar advantages to the VWAP. Another common method for price aggregation would be time weighted average price. This is especially useful for calculating price values based only on decentralized exchanges. Many DEXs even offer their own TWAP based Oracle solutions. For example, Uniswap TWAP Oracle. But besides DEX based oracles, this method can be used to make market manipulation harder in case of a limited amount of data sources. But Redstone uses TWAPs to make the pricing of low liquidity assets for being more stable and reliable. So guys, now we would be finalizing the best method, and the ideal price value actually depends on the requested order, amount, buy sell type, and it should take into account order books on each available exchange with all related fees. This is quite difficult to calculate. Fortunately, a significantly good price value does not need to be ideal by definition. And some combinations of aggregation algorithms described above may work great for the majority of use cases in the DeFi space. Nevertheless, it is very important to understand all the potential risks before building a DeFi protocol that relies on pricing data from oracles, and select the best aggregation method or methods for your use case. And guys, this is where Redstone comes in with its best oracle in the market, as Redstone's mission is to build the next generation of oracles. Redstone has an unrivaled ability to exert significant control over any new data listings, and the result of it is that the flexibility to follow any emerging market trends alongside substantial cost savings allows them to be at the frontier of a new wave of decentralized finance. So that's it for the video, guys. Hope you guys enjoyed the video. Thank you so much, and see you on another video. Bye.